What is a wormhole? Concepts such as the universe, space and time still remain mysterious for humanity. Let's see what this wormhole is. Wormholes are a concept introduced in theoretical physics that try to understand the structure of spacetime. This concept is based on the general theory of relativity and is related to the bendability of spacetime. Here's more about wormholes. 1. Spacetime warping. According to Einstein's general principle of relativity, space and time can be deformed due to the predicted presence of massive mass. This fire is explained as the effect of gravity. The presence of a massive object collapses the spacetime around it, and other objects can diffuse into the space around this collapse. 2. What are wormholes? Wormholes are a theoretical possibility thanks to this bendability of spacetime. This concept can be thought of as a kind of tunnel or short path that allows to quickly overcome long distances. Wormholes are considered hypothetical gateways that would make it possible to travel through space or quickly connect two distant points. 3. Einstein-Rosen bridge. Early studies of wormholes were made in 1935 by Albert Einstein and Nathan Rosen. They named a wormhole the Einstein-Rosen bridge. This bridge refers to a theoretical structure that connects two separate spacetime points. For a mass-energy problem, certain conditions must be met for wormholes to form or to maintain a stable existence. At the beginning of these conditions, the wormhole mouth must be filled with a certain kind of matter or energy. However, such matter is thought to have properties such as negative energy or density. Whether such substances exist in nature or how they can be produced remains a puzzle. 5. Theoretical and experimental studies. Studies on wormholes have generally been carried out at the theoretical level. There is no experimentally confirmed wormhole yet. Therefore, more research and experiments on wormholes are needed. In conclusion, wormholes are a theoretical concept and have not yet been scientifically proven or experimentally observed. This concept is an interesting concept that was introduced as a result of efforts to understand the structure of space and time. So what happens if a person falls into a black hole? Gravitational fragmentation, spaghettization and object approaching black holes can be pulled longitudinally due to strong tidal forces. This is a process called spaghettization because it is thought that the object can elongate thinly longitudinally. 2. Event horizon crossing. If a human falls within the so-called event horizon of a black hole, they can no longer escape through the black hole. Anything that falls within the event horizon is drawn into the black hole and is irreversibly trapped. 3. Time dilation. As you get closer to the black hole, the time dilation effect can be seen, a phenomenon explained by the theory of relativity, where time slows down. To outside observers, the clock of the person who fell into the black hole may seem to have slowed down considerably. For the obscurity, very little is still known about the internal structure of black holes. More research on the consequences of falling into black holes is needed to have a greater understanding. An important point to note is the fact that these scenarios are purely theoretical speculation and have not yet been practically observed. Our knowledge of black holes is limited, and more research is needed to determine definitive conclusions about such situations.